we are now live, so hopefully you should be able to see us now. Sorry for the 1 to 2 minute delay, but really excited to get this webinar started. So today we're going to be chatting about output parsing and extraction, and we're going to jump into a bunch of technical concepts related to that, see some end-to-end applications, and hopefully learn a bunch. My name's Harrison. One of the maintainers of LangChain, the open source Python package. We'll do some quick introductions, then we'll do some logistics, and then we'll jump right into it. So, Jeremy, do you want to start with a quick introduction of yourself?
Hi, sure. I'm Jeremy. I've worked in machine learning and natural language for a couple of years, and it's exciting to be at the stage where we're working on the types of problems that LangChain is tackling. I've been working on a few components within LangChain for a little while. Yeah. Maybe Eugene.
My name is Eugene. I worked with Harrison and Kensho. I spent past 7 years there working on extraction, search engines, natural language processing, and so on. Excited to be here today.
Awesome. And then hello, everybody. My name is Greg, and my background is in B2B products. And for 2023, I've been an entrepreneur in the AI space, and it's been a ton of fun building LangChain.
Awesome. So a few logistics. This will be recorded. You can access the recording at the same link afterwards, and we're looking into putting the videos on YouTube. If you have questions, we're going to spend a lot of time doing audience question answering. Please put the questions in not the general chat, but the Q&A bar on the right. So if you look, there's a general chat box at the top, and then the second one down is Q&A. You can also vote on questions that you think are most interesting. And so after we go through the initial round of presentations, we will go through the questions there, kind of ranked by the ones that people have voted for the most. So please hop over there, ask questions there, and we'll do that at the end. The topic of today's is output parsing and extraction. So we'll probably focus mostly on that. There will be lots of webinars on different topics in the future. If you have questions around agents or any of those other things, we will likely save those for a future webinar. So we're going to keep today very focused on output parsing and extraction. I think that's pretty much it for logistics. So we'll start with some quick demos, 5 to 10 minutes from everyone, and then jump into Q&A. So Jeremy, you are up first.
Great. Let me share. Okay. So I'm quickly going to demo something that undoubtedly Harrison has tweeted out already, but this is kind of a core data structure that showed up in the library related to this subject. So I'll give a really quick walkthrough of, this notebook is checked into the repo, but just to sort of set the stage here. Programming over time has gotten more declarative, and obviously language models have accelerated that quite a bit. And sort of the concept here is, not only are we declaring like tasks or some of like these functional requirements to language models, we can also declare and sort of constrain exactly what we want the output to look like, and meaning here more like structured data types. So in LangChain, we use Pydantic, which is sort of like data classes. It's a nice tool for interface definitions, but also has a lot of kind of nice strong typing guarantees. And the pattern that we've been using and that works pretty well is to specify sort of the data you want out from this black box, from this language model, as a data class, and then let LangChain sort of handle some of the bits below in terms of getting the language model to format things correctly. So let's see. I'll show sort of a demonstrative case. Here's a data structure that we'd like to populate with a language model, and this is some sort of joke, and there's some sort of setup and some sort of punchline, and it doesn't entirely matter what that means. We might get some user queries or some inputs, intermediate inputs to a language model, and the idea there is we want to populate this data structure. In LangChain, we define the schema or the interface that we want to populate. We have a query that's going to do that population, and then we go through setting up sort of the input prompts, the output parsing, and we can run this user query through the model. And and so, and very nicely, like, the language model does this. And you'll note above, I'm using DaVinci 03, and I'll make a note about that in a second. So here's another quick kind of slightly contrived example. And here there's like a structured or compound data type. There's a list of strings within. Yeah, so I mentioned this is DaVinci 03, and of course, like, a lot of folks are familiar with scaling laws and sort of capabilities that arise. If you try to ask too much of sort of a smaller model, then maybe like the capabilities won't be there to actually reliably and robustly kind of populate these data structures. But capabilities are increasing really fast, and we're sort of building for a lot of like anticipated stuff. Here, I wanted to show one more example.
Jeremy, I have a quick question. So this looks like magic. What's actually going on under the hood? Like, this is obfuscating a lot of like really clever kind of like logic and prompt engineering. Or like, I think people would be interested to kind of like hear how that's actually done.
Yeah, absolutely not. So there's some, or absolutely, there's some like little bits here that might give you a sense of what's going on, and it's really this one comment here. Essentially, like this schema is defining some instructions for the language model, and when we build a parser and we reference the specific schema with this parser, we're under the hood generating some instructions to the language model and how the completions should, like, what sort of shapes they should adhere to, and if they adhere to those shapes, then after the language model will be prompted to generate that shape, and then when we get a completion, we'll do some formatting under the hood. So there's some, basically, there's some instructions to the language model as per usual, as in the prompting paradigm, and then at the output, we apply some sanity checks and so forth. So it's fairly simple, right? It's just, these are also just natural language instructions about what kind of non-natural language outputs we want. But there are extensions built on top of this. Obviously, like I said, language models are leaky abstractions. We need really big models to do some of these, or to have some of these capabilities for now. But even still, there's still randomness, and it'll fail sometimes. So we'd like to leverage like other utilities within LangChain, sort of like things like guardrails to make sure these completions conform to what we want.
Can we see what the actual input to looks like? So there's like, can we see what like input to string looks like or something like that?
Yeah, I think, yeah. So here's the prompt explicitly, and it's quite simple here when it's just this raw. So really, it's like a single shot, or I suppose a two shot example here. Pydantic and JSON are you can convert back and forth very easily, and so essentially, like, we've defined some schema up top here, and we've dumped a minified version of that schema into context, and it's really as simple as that here.
And so the descriptions are put in, basically the like name of an actor. Those are all used in this JSON thing, and so that's kind of like, the language model is taking cute. Like if you it's not going to magically know kind of like what a variable means unless you like tell it what it means, basically.
Yeah. So there's this like very, very neat thing happening here that is sort of like the second level or something, where we're actually like, we're not just defining sort of an interface and like what shape we want our data to take. We're actually like defining what we want that data to be, and so we're inducing tasks here by specifying the description on these fields. So if I show like maybe, I don't know, I called this moderately more real world example, and just to give another sense of that. So yeah, in this scenario, I'm imagining it like more of like a conventional chatbot application, which is all the rage right now, and maybe some like customer conversations, like a sales conversation or something, and you can imagine like taking a transcript with a customer, and you want to know like what happened, like did they buy something or did they not buy, and sort of why, and that's like, these are like very common use cases for like the unstructured conversations you get in that setting. So I actually want I actually want like the data structure I get out to basically do classification for me. I wanted to assign a value in this enum. And then I also, I don't just want this classification, but I also want some like summarization, like some abstractive task here where I say also like, why did that outcome occur? So I've defined those, and I set up the prompt in the same way where, right, I've just dumped somewhere in my prompt, I want the instructions on how to format the stuff, and then, you know, pass that in currently via this parser thing. And now here's a customer, you know, the customer output we want to do some classification and summarization against. You know, it does like a reasonably good job here. So it assigns it to the right enum value, and also like the language model generates a reasonable summarization. And you know, you probably scale up this input a bit for full conversations and so forth. But it's quite neat here. It's exactly what Harrison was getting at. That sort of the description of this field induces these different tasks under the hood.
And I like how the description of one field is just why ? And that's it. And the language model still is smart enough to know what to do. Also, if you scroll back down to the bottom, just because I did see a question about this, you can see here that the whole prompt is printed out. And so you can easily kind of get this by setting like verbose equals true in the LLM chain in that line. And then we also have like there's a lot of complexity in these prompts right now. You've got like these kind of complex instructions for how to think about it. You want to make sure that the user inputs handle it okay. So verbose equals true is very handy for that. There's also a concept called tracing, which I'll send a link to in the chat, which basically visualizes a lot of the inputs and outputs to the language models. Because again, there's kind of like this complex pipeline to construct these prompts. You want to do some sanity checks on it, make sure it's okay. So I'll throw a link to that in the chat, because I did see a question about that, and it is a very important part of debugging applications.
Cool. I have, Harrison, I have some bits to show, but maybe you can come back to this a little later around sort of the planning and replanning, but that's a little bit of an extension or a preview off of this, so we could maybe come back after core and so forth.
Yeah, I think the retry stuff would be really interesting to show, but actually, should we just do the retry stuff right now? Because I think that's that should be pretty fast and
yeah, sure. Yeah, I'll show quickly if I can share again. Okay, this is related to parsing, but also slightly different. I mean, I think in kind of the discourse, this topic is the term usually used as like guards or guardrails, where we're talking about you get some completion from the language model, and you know, this again, it's from this like non-deterministic thing, and so we probably want to do some validation, and maybe optionally, like if the validation fails, we might want to you know, try again, basically. Requery the model. And so I'm going to go through this relatively quickly, but just maybe suffice it to say it's a sneak preview of some things being worked on and that will be available. So the application here, I have these different API specifications. If you're familiar with open API specifications, quite popular in recent weeks in this domain. I don't know if this is loaded. Cool. So there's an open API specification for OpenAI, for Klarna, which is this shopping website for Spotify. And the task that I'm playing with here is basically, you know, oftentimes you have a query against some API, but resolving that query actually requires like a couple different get and post requests, and a lot of interesting work, both in like research and an application coming out around language models orchestrating against APIs. But again, we're going to run into some of the same issues around hallucination and randomness and so forth. And so let me show sort of an example here. Generate. So I'm actually printing out a bunch of stuff so you can see what's happening. So my prompt is to instruct this language model, you're some sort of planner, and I want you to string together a sequence of API calls to accomplish some user query. And then I have some few shots here. And then I actually dump in, now here you'll recognize probably a lot of the OpenAI specification here. So when I let's see. Actually, it's working fairly reliably. Here's an example. You'll note I ran it a few times, and sometimes randomly it works, sometimes it doesn't. And I'm using intentionally DaVinci 001, where maybe it's more likely I see some undefined or ill behavior. So what happened here was there's a plan or a sequence of API calls that were generated, but at least one of these things, this endpoint did not exist in my prompt. There is only a post embeddings endpoint. There's no get embeddings endpoint. And basically, it's fairly reasonable or fairly unsurprising that a hallucination like this would happen. But okay, what do we do in an actual application? And so under the hood here, essentially what's going on is I've applied some validation logic, much like where the parsing logic is applied. Gathered that some endpoint has been created out of thin air, and then I've basically reprompted under the hood the language model to okay, I want you to retry with this query and keep in mind the error that you've just made and try not to make that error again. Essentially what's happening there. And I can show a similar example. Here's the Klarna API if folks are familiar with the Klarna plugins that have been released. Here there's actually just one endpoint on this API. And now I have these kind of fake few shot endpoints. And so it actually seems somewhat likely that the model will be confused. And sure enough, the completion hallucinates a bunch of there's no get endpoint with this query param keyboard. And so again, we raise some sort of parsing time or validation time error, and then we can retry. And actually upon retrying, we get something nice out. So yeah, the purpose here is just to show a little bit some of the ideas around what we can do with guardrails and sort of treating the completions as dynamic and so forth. But probably a lot more to say on this later. Harrison, can I turn back to you?
Yeah. No, I think we'll definitely talk more. Yeah, this is a more complex end-to-end use case, and so there's but there's a lot of interesting kind of ideas around. You've tried parsing and it doesn't work. You get some bad response. Either it's misformatted or the value, like in Jeremy's case, the values are actually wrong. So this concepts around parsing and then retrying and then fixing, all kind of related and all a bit more advanced. But anyways, on to the next section. Eugene, do you want to take over?
Hello, everyone. I hope everybody can see the screen. So I'll talk to you a little bit about Core. It's a library I started working on maybe a month ago to try and figure out how to extract information using large language models. It's built on top of LangChain, and the goal is to be able to provide a little bit more of an end-to-end use cases for extraction or query analysis. So the main thing that you're doing is you're also declaratively trying to specify what it is that you're trying to extract. So you specify a schema, and then you also provide examples. And the idea is that by providing a little bit examples that are nuanced, you will be able to guide the LLM to be more accurate and extract results better. So Core uses it's an internal schema definition. So it has a concept of an object, text, number. It's fairly straightforward, but you can say I have an object, it's a person, and you can say that the person actually has an attribute, which is a first name, and provide a few examples of how to extract this object from a piece of text. You say Alice and Bob are friends. I have two people actually in this piece of text. One of them is Alice, the other one is Bob. Once you declare what you want, you create a LangChain chain. And I'm using actually Chat GPT or GPT 3.5, 3.5 as the underlying language model. The nice thing is that it makes things pretty cheap. And then I can run extraction, and I have some test sentences here, and you can take a look at the results. So the response here is a little bit more complex. It contains information about so it has the raw LLM response. It has a field for the data that was extracted. So this is just the decoded response, and then I'll show you in a little bit things that are associated with the validated data. So you can also validate the output using Pydantic. And just what happens under the hood. So this was the schema that we declared. Under the hood, core assembles a prompt for the large for the LLM. So it creates a TypeScript description of the schema. Here it's a really simple one. And then it also collects the examples from all of the fields. And in this case, it uses a CSV encoding. The input sentence was Alice and Bob are friends. And the CSV encoding, this is the column name, this is the first row, the second row volume. And there are different encoders that can be used. We'll see that in a second. So before I show a few more examples, just the two kind of main use cases, at least in my mind, for structuring and structured data. One of them is data extraction. So you might have a PDF or an HTML or some other text document, and you're trying to extract information out of them so that you can put into a database and maybe do power some downstream application. Another use case that I spent a lot of time on is query analysis. So maybe you're trying to write a search engine, and somebody issues a query that says, I want articles about LLMs or large language models from 1992. And you could just write an embedding and try to embed and find similar documents, or you might realize, oh, the embedding is actually not precise enough. So actually, I want to first analyze this query, figure out that the user is trying to find a keyword, which is LLM, an exact phrase, which is large language model, and also apply a filter on the publication date, and then formulate a more complex query that will be more precise or more relevant. You can also use it to power an API. So if you have maybe an API for some simplified music player, and the user is asking you to play Yellow Submarine by the Beatles, you can realize, oh, the Beatles are an artist, and the Yellow Submarine is a song or an album. So this is similar to what Jeremy just showed us. You can also use Pydantic to declare all of the schema, which I think is quite convenient because you also get all of Pydantic's validation capabilities out of the box. So this is an example that talks with a music player. So you can request a song, an album, an artist. You can also say, you can declare an action, so you want to stop playing or play the previous song again. So each of the fields you provide a short description for. If you want, you can provide some examples if you're saying that the parser is not able to understand certain queries. There's functionality to convert the Pydantic into internal core schema, and then.
So Eugene, I have a question about that actually. So internal core schema, why not just use Pydantic? What are the benefits of the internal schema that you wrote?
At the moment, none. So at the moment, just Pydantic. In the future, there might be some. So at the moment, this is just another abstraction. But that's where I got started. So I got started writing my own schema because I did not know that Pydantic could support metadata on fields. So that's just historical.
And by metadata in fields, you mean like description and examples and
exactly.
And I guess, yeah. And I guess actually, yeah. So you have like first class support for like a specific examples field, right? And I guess Pydantic allows you to attach arbitrary metadata, but it's not necessarily like.
Exactly. So Pydantic allows you to just drop in the examples, and I just converted into internal core attribute, which is called examples.
And have you found like when should people think about using examples? Have you found them to be pretty useful in any most particular place, or?
In general, including at least one example, in my experience, really helps the model figure out how to follow the schema correctly. So without a single example, often it will just not produce exactly correct JSON. Or the JSON might be correct, but the fields, it will not capture the schema in the correct way. So you won't be able to actually parse your data. So just a few examples help it figure out what it is. What does it mean to actually follow TypeScript data? But also, I think it helps in some senses, in some situations, to disambiguate in terms of what you mean. So, what is an address? Is an address just a city? Is it a state? Do you need to have a street name for an address to be valid? So, providing a description, a few examples can help the LLM produce better results. But I would just test it out on your use case, figure out if it works. If it does, great. If it doesn't, consider adding a few additional examples.
Awesome.
So this is a test query now, placates Kernel by Yusuf or Johnny Cash. And we got the song request, and we got both artists parsed out, which is fantastic because we hardly had to do anything except for declare a schema. And this is, for this more complicated example, this is the TypeScript that got generated. So this is the schema. And all of the examples were collected from the individual fields to create this section. There are a few tricks that I'm using. So I'm encoding JSON instead of JSON tags. You can also use triple quotes. But some of these tricks help protect against the model trying to provide clarifications, even though we asked it not to clarify anything, and so on. Core supports two encodings right now that I would recommend for usage. One of them is a CSV encoding. The other one is a JSON encoding. So this is, you've just seen the JSON encoding. A CSV encoding is potentially better for a use case where you're trying to extract a lot of information from some section of text.
Why do you think that is?
This is anecdotal based on what other people have mentioned, and also it seems that online advice seems to suggest using CSV encoding if you're trying to robustly extract stuff. So we need benchmarks. So without benchmarks, it's hard to claim for sure, but it seems that there's enough anecdotal evidence right now that if you can just use a CSV encoder, the CSV encoder in the library right now does not support any embedded lists or objects. So it's a little bit less flexible, but potentially more accurate. So here's an example with a very simple schema of a person. The person has a name and an age. And there's a short story here about my grandmother came today. She's 90 years old. Her name is Mary. I'm 30 years old. My name is Alice. Lee is 29. We're all going to a birthday party for Brenda, who is 2 years older than Mary. My grandfather is quite old. He will be also at the birthday party. He is 80. There will be cake. My grandfather's name is Bob. Yeah, you can try this sample text, you pass it to the chain, and the LM extracts the correct results here.
And what's really cool about that is I think the Brenda, who's 2 years older than Mary, so it never says like 92 explicitly, but the language model is smart enough to kind of like do that math and then also extract it. So it's not just, this isn't just like a fancy regex under the hood. It's actually doing logic as well.
Yeah, that's correct.
Very cool.
So more complicated schemas can be composed. You can say that maybe a person owns multiple pets. You actually want to break down the age of the pet into things like years or days or weeks, and you actually have multiple people. So there's a slightly more complicated example here of somebody who owns a dog and a cat. Their age is quoted, and yeah, it just kind of works, which is fantastic. So I think that's it for me.
Very cool. So you've experimented with like a lot of different tasks. It seems like there's some extracting kind of like things that you should do or pass into like a search query or an API, as well as extracting kind of like attributes. What do you think like this type of, what do you think Core is best at the moment? And what do you think like some of the weaknesses or places where it might fail are, either in terms of like applications or types of data or anything like that?
I think, so at the moment it doesn't have some of the obvious building blocks for sorry, it doesn't support the end-to-end use case right just yet. So there's no way of just taking an HTML and converting it into something that you can extract. So you would need to just do that yourself. But I'll try that support for those to try and make it as easy as possible to just load your document and extract stuff from it. I suspect it will work pretty good for query analysis, but yeah, these models can hallucinate results. So I don't know. I think you just benchmark things if you're using it for something like against your own database or against your own search engine.
Awesome. And then one last question before switching to Greg, because I saw a good question that I asked, and you mentioned something around kind of like benchmarks. So yeah, how do you kind of like compare both across models, but then also across different encoding things? So I think the specific question is, did you compare whether GPT 3.5 handles a specific data format better? E.g., does it produce JSON better than CSV or Markdown? Is there anything either qualitative or quantitative that you're doing to benchmark these things at the moment?
So not yet. I think that's on the plan to do. I've definitely noticed that the models can be very finicky to small details, like if you are working with a large piece of text and providing multiple examples and forget to quote the text in quote marks, the model gets confused about where the white space is. So there are some important details to get right, and we need to benchmark and check whether things are what kind of prompt structures work the best. My experience so far is that both Text DaVinci 3 and GPT 3.5 work pretty well for a variety of test cases that I've done. But I would love to hear from folks that are using this to see where things fail and how we can help and fix them.
Eugene, question for you on the hallucination piece that you're speaking about. What's your opinion on where, if anywhere, should reflection be within core?
No opinion yet. So
Okay, easy.
All right, Greg, do you want to take over now?
Yeah, absolutely. So after hearing about core's use cases, I think one of the underrated topics that language models aren't being used or aren't being talked about a lot today is around unstructured data and pulling out structured data from it. And specifically, the use case that popped into my head was when I would talk to old sales teams. They'd say, hey, Greg, we need a leads list. And they often check job descriptions to see which technologies a company is actually using, which is an interesting way to do it. So they'd go to a job description, and in fact, let me start sharing and we'll just jump right into it. So they go to a Harrison, got my screen here? There we go.
Yep.
So they go to a job description. Let's share this. They go to a job description. Here's one for Fivetran right here. And it says, oh, technologies you use. And then they give a list of technologies here. So say you're a competitor to BuildKite right here. That would be kind of cool to know that Fivetran is using BuildKite, so you can put them on your leads list and go and prospect into them. And so I thought that this would be a cool use case to extract this information, but at mass. And what's cool is Greenhouse specifically has an open API. So as long as you have the company names and you have their company token, which isn't too hard to figure out, you can go and query all the jobs across Greenhouse and go and grab them. And so what I did was I just set up basically the demo that we just saw for core. But in this case, I pulled in a few different objects. And Eugene, I want to talk to you about this later because I found a hard time with nesting, but we can jump into that in a sec here. But I created a different object for which technologies do they have? Let me share this tab, sorry. Which technologies do they have? Which tools do they have? And I put in some examples there. And then also I saw a lot of jobs had salary ranges too. So it's kind of cool to pull out the salary range. And this was a prime use case for a language model because these salary ranges were not standardized at all across job descriptions. So it was really cool to not need to do anything more rigid right here. And then you go ahead and you pull the job description, you get the content of what this thing says. And here's that same job we were just looking at. And you can see here that BuildKite is held underneath there. And then you just basically get the correct formatting and then run it. And then you get a list of tools that is output, which is pretty sweet. And so once you do this at scale, you do this across a whole bunch of different companies. I made a quick Airtable because I wanted to spin up a front end really easily, but you do this across, I think I did this across 73 companies right now, which is just a sample of the whole data. You get all their different tools. And then I threw together a front end for this called opening attributes. And it's a lame name for basically, let's check out which tools all these different companies are using. So you can go through and see which tools are listed across their different job descriptions, which is a fun use case here. And I wasn't sure how this would go, but this sign up list, which is if anybody wanted to get it when it was fully out there, since the tweet yesterday, it's had about 50 people sign up, which is sweet because maybe build this out, maybe not, who knows? But that's the project from here, and it's been a lot of fun to do.
And so, Greg, similar question to kind of like what I asked Eugene at the end. Did you notice kind of one, are you doing anything to like benchmark how this performs across various things, or just more like looking at the data? Have you noticed any places where it works well or doesn't work well anecdotally?
Yeah, absolutely. So some things I did not do. I did not do a reflection step, which I think I would have benefited from, because some of the examples that I listed in there actually appeared in the final output. So the language model had a hard time understanding what was an example and what was part of the actual output in the content. So that's something I could definitely do. And then I also found it very beneficial to make sure that my signal to noise ratio was high. So instead of putting the entire job description, which there's some sections I know won't have anything about the tools, for example, about our company, I need to exclude that part because the less text I can have and the more dense information I can give it, it usually does a whole lot better. So pre-processing was actually worth the effort on there.
Interesting. And so you just did that by kind of like writing your own custom logic to clean the text and stuff.
That's exactly it. And so in some cases, it would cut it down between 50 and 60% of text, which was really beneficial.
That's awesome. That's awesome. Actually, this brings up another question that I have for Eugene. So, or Greg or anyone who's kind of like played around with this, but if I have a text and I'm trying to extract something and there's just nothing in there that's relevant, like, is it going to be good at saying like there's nothing there? Because I know like typically one of the biggest problems with language models is they don't know. And actually, this is maybe a great transition to the question answer section, because I think the top question there is like something around confidences. Is it possible to assign confidence to the parsed output in any way? So maybe doubling down on this question. One, is it possible to do that? And I think we can maybe hear from all three of you if you've tried that. But then two, specifically on the extraction side, what if there just isn't anything to extract? Will it actually say like, I don't know, there's nothing there? Or is that a case where like hallucination is most frequent? Maybe we can start, maybe we can go reverse order. So start with Greg on either of those.
I was going to say, specifically this exercise using core, a bunch of blank lists showed up when there wasn't any information there. So it was pretty nice to just have a null, like nothing pop up for me, which was good.
Yeah, in my experience, I've checked a lot with short test strings and also a little bit with HTML web pages, and it's pretty good on controlling for false positives, which I think is a little bit surprising, but also good news.
Awesome.
And things should also just get better with the more as LLMs advance.
Just wait for better models. That's always the answer.
In some sense, we don't need to benchmark anything.
and Eugene, what about the assigning confidence to the parsed output in any way?
I haven't tried that, but you could imagine having another pass with an LLM to actually just verify that the extraction is correct. So two really cool things is verify that it's correct. If not corrected, another thing that you could do is localize it. So tell it every extracted field exactly where it came from in the text. That way you could actually show the document and show the highlights of every thing.
Oh, that's super cool.
And then that could actually be checked by a human now. So if you have a human in the loop kind of a scenario.
Have you tried doing that second thing? And if you've tried doing that, have you tried doing it in just one pass, like extracting it along with the text things in just a single forward pass, as opposed to doing some second step to do that?
I've tried it not in a single pass. I've tried doing it also, but with some test examples a while back. But you can ask the LLM to basically show it like a dictionary of stuff, and you can ask the LLM to repeat the text verbatim, but include XML tags around extracted content with IDs. And it seems to be able to do that. I don't know to what quality though.
Jeremy, do you have any thoughts on assigning confidence to the parsed output in any way?
Yeah, so Greg and Eugene both mentioned like offloading this to another inference pass, which is getting a lot of attention these days, like reflection or self-correction. I mean, it is really great. We can use language models as like cheap verifiers, but to the original asker's question, yeah, it would be really cool if we did like more traditional machine learning models get some like calibrated notion of confidence out. I know there's a lot of work that's gone in to do this for like conventional tasks like classification and question answering. Often what's required is like after huge pre-training and then like alignment on human preferences, no, the answer is like these things are not well calibrated. But often you can do calibration post hoc by like scaling kind of the logits and stuff. So I think that there's like potential there as like a future direction for LangChain to support, because it's not so difficult. You basically like have a bunch of generations and you score them yourself, and then you learn like a small transformation of the output and you can get something. And the examples that we showed where these are like highly structured, I feel like it starts to get like a lot hairier. So in that case, like I would use this, or I have been using, like in more offline use case, a separate model to check for correctness. And then if you really care about confidence, you can use that same separate model and calibrate that thing. It will be much easier than calibrating the initial generation. Yeah.
So there's another related question, less on like correcting or checking for correctness, but around like actual adherence to the schema. So both you guys are kind of like parsing it into the exact schema. And I think we touched on this a little bit before, Jeremy, but like, yeah, what happens if it doesn't adhere to that schema? Like what different functionalities or different methods exist in LangChain? And then Eugene, are you using any of those in core? Maybe we can start with Jeremy.
I think the main pieces that are in LangChain presently are, basically there are like particular parsing exceptions that are thrown, and we can configure these chains so that when these things are thrown, either you can attempt some sort of retry, and so I think just like a simple prompt retry, and like the prompting is really naive. It's like here's the original input, and here's the completion you generated, and ideally like here's the error trace for what went wrong. Often like the retry mechanism is pretty good.
One thing here, if I can just jump in, I think there's two different types of retries in LangChain, and I think there's a really cool distinction between them. One of them takes one of them is kind of simple. It takes the LLM output and it takes the description of what it should be and says, this is the output, this is what it should have been. It didn't work. Or maybe you pass it the error as well, and then it says generate new output. And that's good at like if you have like a misformatted like quotation mark or something in your JSON, and it's not loading, or you don't have like an end bracket or something in your JSON. It's really good for correcting that. But there's a different category of errors where maybe it forgets to like include a field, and that field's really important, but the only way you can actually correct that properly is by having like the original prompt. And so there's two different mechanisms, one by which you just ignore the original prompt and it kind of just fixes formatting, but then a second where you pass the original prompt back in, and this is what Jeremy was talking about. Obviously that's more expensive or most of the time that's more expensive because it's a longer prompt, but in the case where like you're forgetting a certain part of the schema or something like that, it's really good for fixing that. And I thought that was a really cool distinction because it shows how, it's just two slightly different use cases. And so Eugene, are you using any of these techniques in core, or how are you thinking about handling kind of like parsing exceptions?
So not at the moment. I first want to tackle end-to-end use cases to figure out the correct way of hooking these up into just the architecture. So for an extraction purpose, it's actually not obvious that if a required attribute is missing that you actually want to retry, because maybe it's just not in the text. So you want to just now pay double the cost or triple the cost of going over all of the documents and retrying them just because there was something that looked like something that you were extracting, but it actually wasn't that. First I'm going to spend some time trying to figure out how this works for large documents, and then see what kind of correcting behavior we can implement as a second pass.
Awesome. One interesting question. I think these instructions are Okay, two things around these prompts. And so we'll start with the simpler one. Have you noticed that different types of prompts or different types of encoding are needed for different models? So Jeremy, you had one example where you were using like DaVinci 001 or something like that, and even between like DaVinci 02 and DaVinci 03 and then GPT 3.5 and GPT 4, very different kind of like models. Have you experimented with kind of like different prompting techniques for the different models, or is your approach so far has been like find one prompting technique and use that across all models?
So yeah, the reason I had, I guess, DaVinci 001 in that one example is because I wanted it more likely for there to be some like regressions or bad cases, so I could show some fixing. I guess when we were looking at the output parsing initially with sort of like arbitrary schema, we looked at a bunch of like different examples and then tried a bunch of different model families and model sizes. And that's where like the observation came in that like, it's actually like quite difficult to do this with even the best of the open source models currently, and some of the smaller maybe private models. So you definitely have to like do the work up front and like come up with your own small validation set, hopefully, and make sure that like whatever your hyperparameter selection is or your model selection is, it roughly is reliant. Because yeah, it's just such like steep, I guess, performance drop off for some of the smaller models, where they can't really generate like structured data like this. Yeah.
Cool. And Eugene, have you noticed kind of like any differences in the prompts, or I guess you kind of touched on, and no super great benchmarking so far, but any thoughts on prompts for different types of prompts for different models?
So I would, I guess, just echo what Jeremy said. The smaller models seem to be really dropping in performance quickly. So I've been focusing on GPT 3.5 because it's cheap. For extraction, you want something that is reasonably cheap. And then there's just some tricks that you're doing to try to make things a little bit less finicky. But CSV seems to be good. It's just I'll try and see if I can get things like embedded JSONs or embedded objects as part of the CSV encoding, and then I'll be able to say whether CSV encoding is just as robust for complex use cases as JSON is.
Eugene, do you think all the cool stuff you're doing for 3.5 is like playing on hard mode, and that all that work will benefit you when you go to 4?
I think so. I'm a little bit worried that when we get to 5, everything is going to become obsolete and we won't need the package at all. But we live in an amazing time. This is just like the software is becoming better without you touching the software at all, right? This is the underlying models are improving at an amazing rate. This is just like hardware improvements in the 90s and 80s. So you didn't touch your software, and your things would start running quicker by a factor of 2 every few years.
But yeah, I mean, one plug for LangChain though is like certainly the capabilities are gonna keep going up, but we do need the like scaffolding in place, to know when things are going wrong. And so if they do, but hopefully like the amount of time we actually incur like this retry cost or something like that should drop by quite a bit.
Eugene, one question that popped up, and I know you said you experimented mostly with kind of like short pieces of text, but what if a single parser has to extract entities or information from like 2 chunks of text? Like, let's assume that we have to split it into chunks because it's really long. Have you thought about how one might go about that?
Just use LangChain text splitters. So it all kind of works together without too much difficulty.
But then like if there's like a pydantic object that has 2 fields and one's in one chunk and one's in the other chunk of text, like how would you properly kind of like extract that object?
Well, it becomes a bit more complicated, but you could try, run things with, as a first pass at least, write things with an overlap so that there's some overlap. And then the problem there is that you're going to be getting duplicates every now and then. So just have some native deduplication mechanism. And if you are lucky to have humans in the loop, then you can rely on that for whatever your use case is. If not, then you just need you don't have humans in the loop, you're going to have to live with it. You need to accept extraction errors, right? This is your responsibility.
All right, next question, and maybe next question, more on the lines of the end application for Greg and Eugene. Let's start with Eugene on the technical question, and then I'm curious to get Greg's take on it as well. But would it be possible to have a prior step that would come up with a core/pydantic schema for an example text? For example, given the job description, the succession schema would be created by the model, and then just take that schema as we saw. Would be very useful for complex tests where the schema may not be known up front. Is this anything you experimented with, Eugene?
I haven't experimented with this exact test, but a friend of mine described what he wanted, gave as context core documentation, and just got core code written out for him for his task, together with all of the descriptions and some examples filled in, and that worked pretty well. But it's not quite the same thing as going from a document to potential things that can be extracted.
Yeah, and then Greg, I guess my question for you here is when you're building this application, like how hard is it to come up with that schema that you want? What do you think the best UX would be? Would it be kind of like, is having you specify it okay? Would you want to do something like Eugene just mentioned, where you say it in natural language and it generates it, or would extracting it from a piece of example text be the best one?
Yeah. First of all, that's a very cool idea. For my use case,
right.
for my use case here, the schema was easy, so I had no problems with that. However, when I'm developing, I don't want to have an unknown schema and have to handle that, and so I'd feel more comfortable. I knew what it was beforehand. However, that being said, there are a lot of, like, using job descriptions as just an example, there are a lot of nuanced pieces of information just within the content of it. And what would be pretty cool, and I have no idea how, I almost want to do this right when I get off the webinar, is go feed that into that idea and say, hey, give me a schema to organize this information. And then give it another one and say, like, do you need to update your schema given this new piece of information you just had, and have it kind of iterate towards an ideal schema? Because in the job description, like I said, there's salary, there's values about the company, there's what you'd be doing, there's all that other stuff. And it would be cool to use GPT as a schema brainstormer and just have it iterate on a whole bunch of different types and see what it comes out with.
Eugene, is there anything like that in core where rather than, could you define like a blob schema or something, or say like make up your own schema and feed it a text and just have it extract arbitrary key values?
Not right now, but you can just use GPT right now. Maybe we could add something.
Cool. All right. And then final question for each of you. What's next? What's next for the projects? What's next are you guys thinking about? What are you excited about? Maybe we can start with Jeremy. Specifically related to the output parsing extraction stuff that we talked about, not life.
Oh, it's output parsing. I mean, I think these kinds of ideas are going to become more and more core in LangChain and be more tightly integrated with some of the chains and some of the agents, and I'm really excited about that because we'll get to start to see like real end-to-end like production agents, and that I think is like that's the paradigm of software I'm really excited about and that we're working towards. So yeah, needs a little bit more safety and stuff around the edges.
Eugene, what about core? What are some features that you're looking to add in over the next week, month? So
I already mentioned it. End-to-end use cases for document extraction is going to be a push, and then potentially pushing a little bit to the query analysis to see if it's possible to make it easy to query SQL databases in a slightly different way. So not by using intermediate representations.
Awesome. And Greg, what's next for you?
So with that sign up list that I mentioned beforehand, like any other good product, I want to go talk to some users and see if there's enough energy for something like this here. The unique part about this project is sales teams pay a lot for leads often. So there's a little bit of cash on the other end on it. And so we'll see if it's worth the ROI.
Awesome. Well, thank you everyone for joining. Both Jeremy, Eugene, and Greg, as well as everyone in the audience. I think we're going to wrap it up here. A lot of links have been dropped in the chat. Oh, everyone was also asking for links for the demos that you guys showed, the notebooks and the website. So if you guys want to drop them in the chat and then maybe even tweet them out and we can repost there, I think people were really interested in those. I think the examples that you guys showed sparked a lot of imagination and cool ideas. That's it for this webinar. We're going to do another one next week on a very exciting topic to be announced shortly. And yeah, we're going to try to do these every week on topics that you guys are interested in. So if there's a particular topic that you guys want to hear us talk about or have other people bring on, feel free to drop ideas in the LangChain Discord. I'll drop a mention to that. There's a virtual events channel, and that's where we kind of like share and announce and also hopefully get feedback on a lot of these things. Thank you everyone for joining. Have a great rest of your day.